Hey folks, we're excited to announce our next virtual Unreal Build. Join us for Unreal Build broadcast and live events, a free half-day event featuring the industry's most innovative thinkers in sports, television, esports, and more, with insightful fireside keynotes from deadmau5 and other inspiring guests. The fun starts on June 16th. Pop over to the feed to learn more about the show and register today. Just like Mayflowers, this month's free Unreal Online Learning courses are blooming to life. Get started with the essentials, planning, blocking out, and refining your level design, and then dig into optimizing projects for real time. Visit unrealengine.com/online learning to dive into these courses and more. If that's not enough learning content for you, then buckle up for a guided tour on how to polish your automotive projects. Get directions on studio lighting, ray tracing, and environment rendering to create your own high-quality studio shots detailed on the Unreal Engine feed. And creating a single photorealistic car is one thing, but how do you go about creating hundreds of them? At VW Group, the solution to that challenge is the Automotive Visualization Platform, an innovation that began at Audi and now provides real-time configurators, images, and videos for the entire group. Learn more about their global approach to visualization. Anyone who has played Little Nightmares 2 knows how important lighting and moody atmosphere can be in crafting a dark, memorable journey. Read our conversation with Swedish team Tarsier Studios and find out what their favorite twisted enemy is in their suspenseful adventure title. Missed our latest episode of The Pulse? Well, now you can discover how digital twins will be key to improving our quality of life, both now and decades into the future, with a panel of industry experts hosted by Fred Mills, on demand on the Unreal Engine YouTube channel. The dazzling action sequences in Toei Animation's Healin' Good Precure are absolutely unreal, in more ways than one. Find out how Guild Studio got amazing results with a new fast and flexible workflow using game engine technology to create traditional style animation. In case you missed it, the Coalition announced that they are making the leap to Unreal Engine 5 for multiple new projects in the coming years. The Gears franchise has long been on the cutting edge of game development, from a breakout title for Xbox 360 through last year's launch on Xbox Series X and S, and we're thrilled to see the Coalition continue to carry the torch onward. Now to this week's top karma earners, many thanks to Clockwork Ocean, Everynun, Ugmo, Ailcon01, Dr. Caliginius, Luna Nellis, Crewdimer, Shadow River, Mama Marcis, and Lord 7. For our community spotlights, we're kicking off with Path of Kami, a relaxing puzzle exploration game following the spirit of recently deceased Wolf Kazeyo as he navigates the trials of the mortal and spirit world. Wishlist the Japanese folktale-inspired journey from Capdelight on Steam. Next up is the latest teaser for the State of Art Academy's Unreal Engine for ArcViz online course. They're still updating and improving this lovely scene. Hop over to the forums to share your feedback with Sep. Known for their immersive digital experiences, Monochrome Paris is now working on a unique puzzle platformer called Tandem: A Tale of Shadows, set in late 19th century London. With their faithful teddy bear Fenton, explore the Kane family mansion searching for clues about Thomas's mysterious disappearance. Wishlist Tandem now on Steam. Thanks for watching this week's news and community spotlight. Hey everyone, hi and welcome to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Amanda Shade, and with me today I have Alec Moody and Jim Ashcroft, the co-owners of Missing Digit and creators of Wrench. So welcome, you all. Before we dive in, we're actually going to do a little bit of a celebration for our awesome student community. We have our student sizzle reel for spring 2021. We'd like you to give a shout out to all these awesome projects as we watch that here real quick.
stronger every day.
All right. So congrats to all the students that made it to part of our sizzle reel. We're always impressed with the quality of the work you're able to build and create and share with us. In the future, we certainly encourage you to, if you have projects to share and are still a student, please share those with us and submit them to be included in future sizzle reels. So now we're going to switch gears over to that was my cheesy joke for you all. Over to Wrench. And to give you a little taste of what we're going to be talking about today, we have a short intro video to get you familiar with it. All right, so that's a little preview of Wrench. And so Alec and Jim, do you want to introduce yourselves and give us a little bit of background on how this all started?
Yeah, so I am the art half of the dev team, and I originally started this by myself, and I have a background working in video games. I've been doing freelance art, specializing in hard surface props, and a lot of mechanical work for since about 2002. Yeah, Jim.
Yeah, sure. So I'm the programming half of Wrench, and I guess we also share a lot of other responsibilities that don't fit into either art or programming. But I started programming when I was in high school. I've always been a programmer, and I wasn't always going to get into games. I was more interested in robotics originally, but when I was going through college, I started experimenting with some homebrew development on the Nintendo DS and the PSP, and I ended up with a games job actually in the Triangle area with Vicious Cycle, who also had a proprietary engine. It was kind of before UE4 took over the world, and I was an engine programmer there. Did a lot of physics work, rendering work, general core programming. I also worked a little bit with Alec and another colleague of ours on a little side project called Handplane Baker, which Alec still uses to this day. It's a mesh baker. And I also did some work on another UE4 project, which was a pretty, it didn't quite work out, but it was Lawbreakers, kind of a high-profile thing. Cliff Bleszinski was involved.
Yeah.
It was a cool project. It just didn't turn out, and I was a core programmer on that team, helped optimize and make a lot of the systems work for us there. And after that, I ended up with Alec on this project. He needed a programmer and had worked with me before, so we made it work out. Here we are.
So you combine forces to create.
Combine forces.
Right.
That's right.
So you want
So,
to
Alec,
go ahead?
tell us more about the history of Wrench and how this got started from when you started the project.
Yeah. So I was working on a PSVR game in 2017, and we wrapped that up, and we were supposed to jump onto the next game in the series, and then that got canceled. So I was suddenly without work, and I had been planning this out a little bit in my spare time. And I thought, since I don't have work, I'm just going to jump into it and see what happens. So I came up with a scanning workflow for the parts, and I started building up just sort of a really early idea of what I wanted it to be. And I initially thought, I'm not a programmer. I initially thought I could get it running and as a game by myself with Blueprint, and I was able to get a prototype done. But at least after Jim came in and realized that those were not usable blueprints long term. But I did a prototype video that summer, and I think it got about 100,000 views on YouTube, and then got picked up on Facebook and got like 6 or 7 million views there. And so I was like, okay, there's really an audience for this. I should commit. I'm not going to go back to work, and I've just been full time since then.
Yep. And just to clear up what exactly Wrench is after seeing that video, you should probably give a little more details, but it's a mechanic simulator focused on maintaining cars for grassroots motorsports. It's pretty different from most other games. There's a lot of detailed interactions. There are some other car mechanic simulator games out there, but Wrench definitely takes it from a different angle. We want it to be more like a real mechanic experience, and want the player to take ownership for what they do, give them the ability to swap out parts in different areas of the car. Also, it was built ground up for VR. So this is something that changed. We originally built a demo in VR for Oculus, and that was live before the actual game. And then later we decided it would probably be wise to add desktop support, and it took a lot of work to get those functioning together without a lot of issues, and we'll talk about that later. But originally it was VR, so a lot of our interactions are optimized for VR. Anything else you got on that, Alec?
Project history. Part of why I wanted to build this is it's a game idea that sort of combined a bunch of unrelated interests and hobbies of mine. And I think when you come up with a game idea and you realize you're one of the better people around to actually execute on it, it's hard surface art, which is what I do for a living. I play with cars for fun. It's my hobby. I have a photography background, so the photogrammetry side was something I could handle. And occasionally I have to do little fabrication projects to fixture stuff and get things ready for scanning. And I'm comfortable with some basic welding and fab skills. So it was sort of I realized there's not a lot of people who could do this with just one person on the art side, and that was a pretty good indication that I should jump into this. And then I guess other things in the project history that were pretty big, we did a deal with Castrol. I think I actually finished making the deal in 2018 to get some funding and branding the oil products in the game. And then that Oculus demo was pretty big. And yeah, we just continued to have pretty good traction on social media, especially through Facebook, and made it to what we considered early access eventually.
Yeah, there was some point in there where Alec kept bugging me because we had worked together before on this other tool, and he had a good experience with working with me, and we had a pretty good collaborative environment between us. And so he called me a few times and was trying to convince me to work with him, and I was trying to do figure it out in my head as all right, am I gonna do this? This is a pretty big commitment when I could probably transition into a more comfortable job. But it sounded like an interesting enough project, and I love challenging programming problems, and it sounded like this project would be full of all kinds of interesting new problems to solve. So I jumped on and took over the programming, and I think it was, I don't know, 7 or 8 or 9 months after I came on that we actually launched our first early access build.
Yeah, I think that's right. It was very early access.
Very early access for sure. And I mean, that's one thing we should point out too about our project is, being in early access, it's hard, but it's also really good. I mean, it's hard to put out a product that you know isn't finished because people will give you feedback, and you know that it's not the quality that you want to show the world, and you still get negative feedback about how it could be better. And you just have to take it in stride and know that you're going to work over months or years to improve the product, and eventually it gets better. And that's definitely the path we've had on Wrench, and we're a lot happier with it these days. And we should give a quick shout out to our Discord community because they have been great. Generally, a very positive community we have on our Discord page, and they help new users solve problems. They give us good feedback, and we try to incorporate some of the feedback. You know, sometimes as developers, you have to make a decision about what actually makes it into the game. We can't put every feature in that everyone wants, but we have tried to listen to our users and make the game better.
Do you feel
I think
like releasing it in that way and having the community kind of go along with this journey for you was like core to the product you have today?
I think definitely. Yeah, I think it's really easy when you've been working on something for, in my case, it had already been a couple years. You're too close to it, and you don't really know where it's bad or where it's good, or like how big it needs to be. And it really helps get perspective on what needs to change in the game or what needs to be done.
And I think also we had a hard time originally fleshing out a lot of the game. I mean, we had essentially our initial release was barely more than a tech demo, and we kind of knew that, but we didn't have the full design ready at the time. But we had an interesting experience that we could give people, and that gave us a framework to get feedback on, you know, what people find interesting about the experience. I think it probably we wouldn't be where we are now had we not been in early access. We would have been designing the game in a smaller, isolated box, and we wouldn't have known how to make some decisions because there's not a lot of similar games out there.
And the ones that are
So
out
it
there,
definitely-
I mean, we very intentionally don't do things the same way. So it's like there's no expectation for how any single system of the game should work, whether it's like interface or part interactions or really anything. It's all just sort of been a from scratch approach.
I think typically that's been one of our primary mottos is like, if we want to do something, we don't necessarily go look at another game and try to duplicate what they have. We just, you know, call each other and have a discussion, look at feedback, and try to figure out really what is the best solution to this problem for our game. And it may take some time to develop, so it's not always there immediately, but I think that's been a good path for us, and it creates a different product. And I think generally it's what's great about indie game development is there are so many different ways you can build any small game or large game. So every game that someone makes is going to be a unique blend of their talents and skills and thoughts. And so I think indie development is a very interesting thing to do. It's always not always easy to undertake that challenge, but it's rewarding when you do.
I would say also, I think we launched, I mean, as much as early access has been great, we launched too early. Like, we didn't really have a choice. It was either launch or don't have a game. And there's been a lot of good lessons in there. You know, being a developer on Steam is a whole set of skills you've got to learn. We didn't really understand how the storefront worked. Interacting with the community, we had to figure out how to do that. It was a lot to do at once, and you're putting out a product that you know isn't really ready. I think that's especially like obvious when you look at like the tutorial system and how we essentially in the first release didn't tell people how to play the game at all, and it was an entirely new experience. And I was like, oh, people probably want to know what they're supposed to do. Yeah.
Right?
Yeah, so I'm
People,
gonna
like try to pick up things and figuring it out, but yeah, you know. But I
Yeah.
think did it also give you a learning opportunity to kind of see where people could pick up and what was intuitive about the game or what elements were less so, and where you kind of had to lean into your tutorial? Did you feel like that was still valuable, even though maybe not how you would approach your next project?
Well, yeah, I'll talk a little bit about the tutorials because it was a huge challenge on our project. And I think game developers take a lot for granted when it comes to people knowing how to play games in general. I mean, if someone picks up a first-person shooter or a top-down RPG, there's a lot of expectations built around that. Like a first-person shooter, you equip a gun or a weapon, and you left-click the mouse, you move with WASD, and the game works. Someone can get into almost any first-person shooter and play the game. Our game does not have a lot of expectations built around it, and so we had, I think, more challenges than some other games might have had for teaching players how to play. And we launched way too early, like Alex said, and I'm going to show some images.
I think it's compounded by, we're teaching people how to play a game in a genre that's not well developed, and a lot of people don't know how to work on cars. So we're teaching like two pretty big things all at once, and you're combining that with teaching in VR and on desktop, like 2 interaction modes. It's a pretty big pile of knowledge just dump on someone at the beginning before they can play.
Right, and the assembly mechanics in Wrench, and we have sandboxy manipulation of objects, which is in virtual reality and desktop, they're a little bit different. There's just all kinds of unique stuff. So originally in Wrench, on our first early access release, we had this when you started a new game, like a giant, ugly block of text that's floating in the air that says press the tab to grab the tablet and get started. There was a robotic narration for this. It was very interesting. I don't even know why we added that.
Was that you, Aldo? Did you do the voice for that?
No, it was text to speech. We planned to replace it with a voice actor at some point, and then we realized it was just a terrible idea. I think we thought that people don't want to read a big block of text, which is true, but also people don't want to have a big block of text read to them. That's not actually any better.
Yeah. So
Fair.
It told you, like the robotic voice said, press the tab to get the tablet and look at the help app to get started. And we have all these help topics. So we did have information in the game, but what we expected the player to do was to read this big wall of text to play the game. And, this was an early access game, basically a tech demo. So people that were invested at that point probably put up with a lot more than a fully released game. But we did get a lot of negative feedback just for the game being confusing to play at first. So I don't recommend shipping a novel game idea with a lack of a tutorial system unless you're willing to get some negative feedback on that.
I would say also it's surprising how little, in the scheme of things, negative feedback we got. I know we always wonder, how did we not get like a 50% review score on Steam the first couple months, because it was bad.
We like to think that the game had good bones.
Yeah, and it was
the surrounding
an enthusiast
part was,
audience too.
So this was the first pass, and then a few days later, so we released on December 19th, I think, and then for some reason we decided to rush out another build and fix a few things from all the negative feedback. And this was the next build. This was on Christmas morning. I was making a build on Christmas morning. I have kids, they want to open presents, and so like before they're up, I'm like making a build to get it on Steam and Oculus. And that was interesting. The indie game dev life sometimes is challenging. But what we did here is we added a little bit more information on screen. And this was like our hot fix, quick patch to get people to fix the critical issues. Like originally, people didn't even know that they had all these tools available unless they read through all that text. And so we put some information on the screen. This is desktop. VR was a little different, but this solved a few of the problems. It was still not very good overall. And then a few months later, I think after launch, we focused on the tutorial system actually, because that was our primary negative feedback for the game. It's just like, your game is neat, but I'm having a really hard time getting started. And so we really wanted to focus on that. And so the next step, we wanted to teach the players more about the user interface. And we have this tablet in the game, which is shared between desktop and virtual reality. And I'll go into some detail about that a little bit later about how that actually works. But we had a little guided user interface thing. Now, all this text was also narrated. Another bad decision. It's also too much text. So
it's probably if you're making UI like this, if people can't figure it out pretty quick on their own, like you've done it wrong.
Right. But on this one, we did, after you got through the user interface tutorial, we launched you into these assembly tutorials. And this was a big help to players so they could kind of come to grips with how the assembly systems work in our game and how to use some of the tools. We would walk them through that. And you'd build a workbench, and then we would launch you into something complicated like building an engine, which was too complicated for new players. We shouldn't have had this in the tutorial system at that point. A lot of players that had more experience with cars did enjoy this, but it didn't belong in the tutorial system. Also, we have a nice little Springy there. He was like our paperclip avatar.
Yep.
Would tell people what to do. He was the
Is that his name? Springy?
body behind
There
the
was a brief time
voice.
when he popped up in a yellow window also. I don't know if you remember, Jim. Like a text bubble.
I don't remember that.
Yeah.
And so this was a solution that lasted, this tutorial system lasted, I don't know, several months. We still weren't happy with it, but it's what we had at the time. And, I'll tell any indie developer, it's hard to find the perfect solution at any time for any problem. You can't just snap your fingers and have something ready to go. So you just have to work toward better solutions as you go. And that's one thing we've done with the tutorials. And we have yet another iteration here. And we decided we wanted to be sure the player knew what they needed to know to play the game. And the way we would do this is have a series of tutorials that the player has to go through before they can do anything else. And we started with very basic things like movement and how to grab objects. So you pick up a ball and you put it in a box. And we would call out the hotkeys, tell them how to do everything, make them repeat the task so that we know that they learn the inputs. I think in the end, this was a little bit too much. It took a long time to get to the main gameplay.
I think it was over an hour for new players, which was like you can't.
It was a long time in tutorials, and we even had like a job board with the training jobs that you had to go through before you ever got to your garage. So you were in this gray, bland environment for 1 or 2 hours, depending on how quick you were. And so we had to teach you things like, oh, you need to be able to inspect parts. And we had a tutorial where you have to inspect all these tires and sort them into the bins. And this was our solution to say, how do we make sure the player knows how to inspect parts? Because if they don't know how, they're not going to be able to get the full enjoyment out of the game. It went on. So there were a lot of these. I spent a lot of time programming all these tutorials, and I will tell you something about programming tutorials. It's hard. You have to add a lot of hooks to different parts in the game which don't normally need programming hooks. And so it kind of creates a network of dependencies in your code. So tutorials in general are underestimated in terms of how much effort they take to create. And now, last year, we finally figured out a decent solution for our tutorials. And I'd like to show a demo of it just to give an idea of how it works. It's still not perfect, but I think it gives a better introduction to the game, and it's more flexible. So we wanted to shorten the time the players required to spend in the tutorials. We wanted to make them optional, and we wanted to make them more bite-sized and digestible while still teaching people the critical skills to enjoy our game. So I'm actually going to launch this in VR.
I think one of the nice things about the new system is it's not a rigid linear structure you have to follow. You can do as many or as few of the things, and it gives you immediate feedback if you did it correctly.
All right, here we are. So, push my chair out of the way. All right, we're going to start a new game. And when you load into the tutorial system, this is in pretty much our current build. It gives you a basic dialogue that tells you, welcome to Wrench. This is a training area. If you complete the training, you'll get a starting bonus when you start the actual game. And so we give you extra money if you go through the training. And we also say it's not required. And we have the exit doors are visible. So anytime if a player wants to start the game without doing any training, they can just walk over here and leave. But I'll start the training and just give a quick example of some of the things we teach. So there's this game board-like path that the player can follow. I'm going to skip the very first tutorial. I'll go to this one, which teaches you about grabbing parts in VR. And so we have just a bullet list of tasks for the player to do, and just little digestible nuggets of information about how to do each task. So you use the grip button on the controller, to grab things. You can also pinch. And so we call these out, and they're different tasks for the player to do. So if we pinch something, you get an immediate feedback.
There's also audio
You pinched
feedback
apart.
too. It's a very quick reward.
Grab a part in VR, drop it. And so every time you do one of these tasks, it checks it off the list, and so you have a very responsive tutorial system. So we're going to move all the parts to the box. You can throw them.
It's the first thing I do with anything in VR.
Oops.
I just chuck it.
Kind of missed on that one. And then once you're done with all the tasks, it says continue to the next station. So we try to make it as simple as possible while still teaching people everything they need to do. And I'll give another example of something that's critical in our game, which is interacting with nuts and bolts and wrenches and that sort of thing. So this is still a lot of information, but it's all critical. We try to boil it down to as little as possible. So for here, for example, I already know how to grab things, so we don't have to teach people that. We tell people you have to install bolts into the correct locations and see how they slide nicely into place. Put all these here, and we talk about the torque requirements. And on this screen, I tell you the target torque, for example, for this bolt caliper guide pin is 40 Newton meters. So we have a wrench right here. We adjust our torque setting down to 40, and the torque does matter in this game. So we attach it, and we run the bolt down, and then we manually torque it. And you'll notice I have these ghost hands that show up. And that's to give the player feedback on where their actual hand is versus the attached hand in VR. We do a lot of little detailed interactions to make it feel good. And so you can tighten these. We're going to go down to 30 for the next bolts. Go down. All these bolts are thread pitch accurate. Alex sets all that up.
Yep.
He's got all that information.
So I have the
So-
bolts.
And then once you've done all the tutorial stations, you can just start a new career. We have an expert mode too that lets people start with more money just to have more of a sandbox experience.
And the nice thing too with this is you could tighten one bolt, get your $20 or whatever it is, and just leave. There's no commitment. So
And then you start the game, but I'm going to exit.
You mentioned that
And-
you were showing where somebody's hand was versus the in-game one. Did you get a lot of feedback that your players had felt like they could connect with that, or they were struggling when those didn't line up in the moments where you were actually like grabbing and the hand was stopped?
I think we added that when we added full part physics collisions all full time. And it's we do Jim will talk about it later, but a fizz handle attachment. And that's, I find when your hands disconnect and there's no feedback of where your real hand is, I can find that pretty jarring. So it's something we added to improve comfort. And it gives you a sense
think
for
we-
effort, because if you know there's a disconnect, you know some force is happening between your hand and the VR hand.
I think we actually added it to the wrenches first at one point, because if the visible hand comes off the wrench, you lose the realistic connect between your VR hand and the wrench. But it's also confusing when you don't know where your actual VR controller hand is in the game, because when they're not moving at the same time, it can confuse your brain. So we thought the ghost hands were a good addition to kind of resolve those issues.
And they come and go in a really
There's little
quick
things
way.
like that. Right, yeah, and there's all kinds of parameters we use to make them show up at the right times, fade them in and out. And these little things, little polish items, really can take a lot of time to get right. And I feel like sometimes, some days we just think we haven't done anything in a long time, but really sometimes we just work on a lot of little polish items
I think that was especially
that make the game feel
when we
better.
first launched. It was we were in putting out fires mode. It was this is bad, this interaction's bad, this training's bad. It was just getting it to a state that wasn't terrible. And there was a good core mechanic in there. that engaged people, but there was a lot that needed to be fixed. But I think now we're at a point where the number of sore thumbs is pretty low. We can actually worry about like making the game better, which is pretty cool.
Right, the game loop. I do want to show in the editor just how we have the tutorial set up, because some people might find that interesting. Generally in Wrench, we do a lot of dynamic loading just to prevent having too much stuff loaded into memory at once and not have a bunch of hitches from loading stuff in the foreground. So tutorials, I have one, what I call the tutorial design level, which you'll recognize the game board from the, I don't really want those to show up. Oh dear. There we go. Volumetric lighting cache. So here's our game board, and the little gear icons for each tutorial station don't show up here because those are dynamically set at runtime, but at the different locations we have little actors that are placed down that have a little bit of information. They have a level that gets dynamically spawned, which I'll show you one of those in just a minute. And then inside that level, there'll be a tutorial actor that knows how to run that tutorial station. So it might need to reference actors in the level and keep track of all the goals that the player achieves, give feedback, and reward the money bonuses for those goals. So each one of these has its own tutorial level that gets dynamically loaded. Some other details in here. And so let me go pull up where those levels are. We actually generally do a lot of these in one level. Like I call it a tutorial station authoring level, which has a lot of sub-levels in here. For example, here's the fastening tutorial station, which I demoed briefly. And we have several bolts placed down in the wrench here on the table. And there's also the tutorial station actor, which that's the actor that tracks the progress in that specific tutorial station, and that's actually in C++. I'll talk a little bit about blueprints in a minute, but this tutorial system came around after we started doing some C++ work.
Yeah, because Wrench was all blueprint 100% until, last spring?
We started doing a little bit of blueprints, I think 9 months after
C++.
After launch. I was looking at it, yeah. It was actually for the physics, whenever we enabled the physics.
Which that was good. I mean, pros and cons, but Blueprint let us get going quickly, and that was how I was able to make a prototype.
Right. So here's the grabbing tutorial station. See all those parts there. So just a little glimpse at how we set those up. And these blue and red squares, I put those down as reference because they are relative to the size of our little game board tiles in that tutorial area, so that we could place things in the correct location and not have them overlapping the game board tiles too much. So, yeah, so I think, are there any questions that have come in yet we need to answer?
We have a few if we want to answer some of them. So they're actually wondering if, like, when you got started, you were saying you built them in blueprints. Did you start with a template, or did you actually just start building the whole level from scratch?
I originally started with just it would have been Unreal 4.1.4. I don't know, one of the early builds that had a VR template in it. We ended up redoing, for our uses, a lot of the basic interactions. But there was, we still use the same teleport visuals. I have not replaced those yet. I've been meaning
That's not totally true.
Did we tweak them?
We tweaked them, or at least we removed part of it. We don't do the directional teleport like was in the template. I mean, basically, the bones of the original ER template are there. If you pull up my editor again,
still called Motion Controller Pawn.
We still have the original blueprint folder that I think that came from that template.
Yep.
And apparently it's BP Motion Controller 1. I don't know if someone copied it at some point. I feel like there's some stuff that maybe Alec didn't know about
Yeah.
Unreal Engine before I started helping out. And some things never get fixed because they're not a problem. But yeah, we did start off with a template. I mean, this is a good segue into blueprints in general. And that's kind of another big topic for Wrench. And, by trade, I'm a C++ programmer. That's actually the first language I learned. In high school, I got a book, like, Teach Yourself C++ in 21 Days. And I've kind of been doing C++ programming since then.
Is that all it took?
I don't think that's exactly right. You can, like, run some demo programs, probably. But I wrote, like, some chess programs using, like, just text output. It was pretty interesting. Anyway, I like programming. I mean, I think programming in general is like Legos for adults, kind of. Not exactly, but... And so then Alec is trying to get me to work on this project.
I would say even before that,
Hey!
though, like if I just made the art and not had what looked, I mean, it functioned, it just wasn't maintainable. If I hadn't had some basic functionality, there would have never been traction or attention, and it just never would have gone anywhere. It would have just been a pile of art. So yeah, having something that I could, like, my non-programmer self could get something functional with was pretty huge.
Right. Wrench wouldn't exist without blueprints.
Yeah.
So that's definitely a benefit of blueprints. I mean, people that aren't programmers can create things. I think that can turn into a dangerous trap, but
yeah,
it is a good way to start something.
You just need someone to know what they're doing to come in and just replace everything you've done.
Yeah, basically. Alec wanted me to come on the project. And he's like, yeah, this is all in blueprints. And my C++ programmer inside me is like cringing. Is like, ah. And blueprints have their place, and I think they're great for their own uses, but I really do like C++ better personally. But part of the project requirements that Alec and I talked about originally is we wanted to keep everything in blueprints. There were some questions about the project future, how long I would be on the project. There was a lot of uncertainty at the beginning. So in case I was unable to stay on the project for longer, Alec wanted to be able to at least conceptually take it back over. Yeah. I think at that point it would have been hard for him because the complexity of the blueprints.
Yeah, I realized that after a few months that wasn't going to happen.
Some of the stuff I create in blueprints would be hard for him to digest and maintain. Yeah, so we got a long way with blueprints, and the initial launch was fully blueprints. The game was in a blueprint-only project for, like I said, 8 or so months after launch. And I was able to re-engineer a lot of the basic stuff that Alec had created to make it more scalable.
I think I got to the point you could
more
put stuff together,
configurable,
and there were some tools, and you could use fasteners, and that was kind of where I stopped.
Right. Yeah. I mean, I think I reworked most of that eventually,
yeah.
But it definitely wasn't quite scalable enough. And then, using blueprints to make a sandboxy game is kind of hard. Like, one of the major hurdles that we had to deal with was saving the game state. In a sandbox game, the player can do all kinds of stuff. They move actors around your area. They can install these complex assemblies together. The parts track race hours, wear, and you can paint different things. There's a lot of information to save. And so I'll show editor how we managed this in blueprints. And it was kind of a question that I wasn't sure when I first started on the project, like, how are we going to save the data? It was just one of the tasks I had to do before we launched. And I guess one thing to say is that UE4 doesn't provide, stock a way to save a bundle of actors in the state, which I think is fine because every game needs to do it a little bit differently. But it's something that can be challenging. I think there's some plugins that handle this, and we looked into that, but I didn't want to rely on third-party plugins because that creates another dependency chain. And if you have bugs, how do you fix bugs in third-party solutions? I'd rather have all the solutions programmed ourselves, if possible. And so what I ended up with was kind of a straightforward solution, and some people might find it surprising, but basically I have a giant struct that has all the different types of things that can be saved. It has information about the classes that are involved in a save file, all the actors, the components, which, you know, actors can have components that need to save data, and the components point to different data fields. Now, this would be something I think Alec would have a hard time like digesting this to fix bugs in it if it ever failed. But each of these is an array of structs. So UE4 can save basically a struct in the save data, and you can do as much as you want with it. So I have this giant struct that has arrays of structs, and so it's a big data set. And this can, you know, be like 20 or 40 megabytes for some people, depending on how many parts and assemblies they have. And I'll just find one of these, like, what do we save for part data? So here we go. And it's also interesting. SGV3 is the name of these structs because it's version 3 of my save data system. And I just ended up calling it Save Game version 3 because I did a few iterations before that, which were more generic. They're just harder to debug and understand. And so when a part wants to save, there's this struct. It's got a GUID, so I can find the parts easily later just without having a pointer to them. We keep track of a time of failure that's hidden from the player so that parts can fail within a range of time. We track the actual race hours, which this is like the wear for a part. So as your car participates in race events, the hours on each part on the car increases and eventually the part fails. And a few other pieces of information. And that gets serialized by the Blueprint Save Game Processor, which runs through all the actors. It's somewhere in here. I mean, this is a kind of a big blueprint. Eventually, it'll call an interface function that would be on a component here, snap part component, which is kind of a giant mess of blueprint code. And this still is what runs the majority of our assembly system in the game. I do plan to move it to C++ at some point, but it's just not there yet. And it builds this little struct. So it takes this interface call serialize, and whether it's loading or saving, it builds it based on the data on this component and passes it back to the save game processor, which have some hard-coded numbers here to tell it which type of component data it is, and it just feeds it into one of the many component data. And there's a lot of code behind this that makes it all work. It maps the components back to their data and reserializes it when you load a game. But it's all in Blueprint, so I don't know. I just wanted to share that you can do a lot with Blueprint. You can take advantage of structs when you need to for some performance gains, but sometimes it's good to realize that blueprints can actually be quite powerful, what you can do. But we are slowly moving stuff to C++. And that's another big challenge, is how do you take a blueprint-only project and start to merge it into C++ without getting too much friction, because from C++ you can't easily access blueprint functions. You know, you could do it through type reflection, but that's not a very performant or effective way to find things, and you would have to know the call signatures and box parameters and all that. So instead, what we did as we started to move stuff to C++, I'm going to pull up a little bit of code here, is I created these interfaces, and they have the very creative name of like ICPP to BP, which is like C++ to Blueprint. These are my interfaces that let me call into Blueprint from C++. And this one is for parts. And so I have quite a few functions here it let me interact with the Blueprint part system from C++. So if I need to like change the where on something for tutorials or for jobs, I can enable physics, which is more complicated than just setting the root component to simulated because of our assembly system. So there's a lot of different interface functions that I need to call from C++ to Blueprint. And an example of calling into one of those from C++ would be like here's our job system needs to spawn a car, and we have like these parametric jobs that have a list of parts for each different job type, and it needs to find the parts on the car that the player needs to fix, and it will fail those parts on the car after it loads in so that the player has something to do. And so I have to find the part on the car and then just set the where and fail it. And this is not that exciting, but it's something I had to do because the part system was still in Blueprint, but my new job system I wrote in C++ because I could do some more complicated logic more easily in C++. And so then if we go to the part in the editor, I'll show where some of that gets handled. So I have the base part,
Jim, do you want
snap part base.
Do you want to talk about the parts assembly
that?
system? Because I don't think people understand how our part system even functions at a sort of core level.
Yeah, I'll get to that in just one second. Like, for example, here's the interface call, just showing how it gets hooked up between C++ and Blueprints. Just to wrap up the Blueprints, generally I would say they're very good at prototyping, very quick. There's no boilerplate. And if you've done Blueprint coding and C++ programming, you know that the C++ side can be heavy with boilerplate code. You just have to tag all your U properties. You have to make sure you get your class definitions correctly. It's a lot of extra code, but Blueprint, you just create one in the editor, add a few nodes of code, and you're good to go. So it's very fast, but it does have some other issues. Anyway, let's move on, unless there's any questions.
Let's see. I think a lot of the questions that you have are actually going to be about things you're about to go through. So I may hold off just a little longer on some of them.
Okay, yeah. So I'll talk a little bit about the assembly system in general, and in a minute, Alec will show in the game, how it works. But our assembly system is one of those unique problems to wrench that most games don't have. So there's not a lot of examples to go by. A lot of this was created just from the ground up. We have these complex assemblies with hundreds of parts all packed together. They're attached together. A lot of the parts are very small, so we individually model like the entire engine assembly down to the bolts and little valves and valve seals. So there are a lot of things packed together. And it was a challenge to figure out the right systems to make this all work. And we had to, we wanted the player to be able to remove sub-assemblies from the car and work on those independently. So we couldn't just have one master assembly that has all the parts and then hide the ones that the player takes off. We wanted the player to be able to actually remove an assembly with multiple parts on it, put it on a table, and work on that separately. And there were a lot of things to work through. And I think, Alec, are you ready to
Not quite.
demonstrate some of this?
Just fighting. Almost.
I guess there were a few other things too to mention that we wanted the player to be able to swap different parts at the same location. So, for example, if you have a car that you want to take to the racetrack and you want to install an aftermarket part, and we need to install a different part on the same root part. So you have your engine block, your cylinder head, and you want to install a different manifold there so you can have a turbo on your car instead of a naturally aspirated engine, then our assembly system had to support different parts getting attached to the same location
So I'm ready. now,
based
Jim, if you
on
want me to-
other rules. Okay, yeah, you can take it over for a minute.
So I can show that. So part of what Jim's talking about is we don't define all the install locations or the install rules on a parent object. It's all passed up a chain through hierarchy. So in this case, this engine block and the cylinder head has an attachment for a manifold. We can put a naturally aspirated manifold on, or we can put this whole turbo manifold assembly on. And this is partly because we wanted to build a system to be super flexible. So like you can disassemble sub-assemblies off the car. We can have aftermarket assemblies where we have a different configuration of parts, and it'll all still follow a set of rules and pass up the chain. We also have a lot of systems just related to polish for the assembly tools. The linear installs are a big one. So if I start pulling some parts, we have these physics interactions in parts that are nested, and even this tire is relatively nested. I mean, there's collision volumes through here that are not this complex collision. We can't just run collision with physics on the high detail meshes. So if you see here, it slots in, and it gives you a sense of physicality as it installs.
Right, I think when we first launched, some people were convinced that we like had some very high detailed physics simulation going on. But it's really like a combination of physics while you're holding an uninstalled part, and it goes to like a programmatic animation system when you're installing something. So it gives a pretty good transition between manipulating a free part and installing a part into a location that it fits.
How precise do you have to be as you're like working with each of those assets and installing them, or as you're unscrewing or unbolting them out?
So it's kind of funny on that because originally we wanted the player to have to align the bolts correctly. Like, actually in our part system, each socket, which is like what we call a location where a part can be installed, has parameters for the tolerances that you're talking about. Like, does it have to be within 5 centimeters of the socket? Does it have to be within 2 centimeters or 10 centimeters?
And angle too.
And the angle, right. And when we initially launched, I think we had the angle tolerances very tight, like 30 degrees, which sounds pretty forgiving. But when you have a person who's new to VR and they're not good at manipulating parts, it can be hard to get the part in the right orientation. And so a lot of times people would have the correct part and they would be trying to install it where it goes, but it would be off angle a little bit and they'd be confused, like, why isn't the part going on there? And so
I
I
think you
think
can see here it's about 90 degrees. So if you come in backwards, it's not going to install. But if you come in anything approaching the right direction, it'll slot in.
right, there was a build pretty early on that we just axed almost all the angle requirement. The distance requirements generally are smaller for smaller parts and larger for larger parts. There's a few cases in desktop mode in VR where we have to offset the invisible install location from where the socket actually is so that it feels better. And that's just something we iterate on whenever we add new parts. Usually Alec goes through when he's making new parts and just tweaks all those parameters until it feels good. All right, so yeah, I want to talk a little bit too about how the assembly system affects the game loop, because it does a lot more than just let you build things. It's a mechanic simulator, and what good is a mechanic if you don't have problems to solve? So one thing we have in the game are called symptoms, and I'll show off something real quick in just desktop mode. And the game does work in desktop mode and VR. That's been a big challenge overall. So
it's also interchangeable. You can
load up-
switch between. So it's not like you start a desktop career or you start a VR career. Like everything has to be stored and kept in a position to be usable for both, be it like in inventory or
Right, so I'm going to load up a car here. And this car is a complete assembly. And in our garage app here in the UI, we have a test car button, which will conceptually, it's the driver taking it out for a spin to see if the car has any issues that need to be resolved. And right now, click it, you get a report. This will get polished a little bit later, but we get okay on the assembly, the engine, the mechanicals, race checks. We do have a few symptoms that aren't breaking the assembly. It's reporting something about the transmission gear oil and the brake pedal. We're going to ignore those for now. So I'm just going to show an example of something which would create a symptom. So I'm going to get out my impact wrench and I'm going to take off 2 lug nuts from this tire. All right, so probably not wise to drive a car with 2 lug nuts missing on a tire or a wheel.
Especially
So we're going to go back here, test the car.
high grip tires in a motorsport setting. Yeah, not going to go well.
Right. And so now we have a failing symptom on our mechanical side of the assembly, and it says there's a massive clunking and rolling vibration, even at low speeds. And so this is just an example of, how we use the assembly to generate meaningful gameplay. And there's a lot of code behind the scenes that processes the assembly. Most of it's data driven. We do have some code that generates symptoms for more complicated situations. And then if I reinstall these.
The other thing too is, we do symptoms for failed parts. We also do them we make a lot of parts technically optional. And if they're missing, we don't tell you the part's missing, but we'll tell you what the car's doing. And that one's fun because people will build an engine and miss something in the innards, and they've maybe got a couple hours into putting it together, and then they get told it's knocking. You got to figure out what it is. So we get a lot of people on
right, in this case
being like, I got a no start or a knock. What is it?
Right. So here we don't have a perfect symptoms yet. Like here, I took off the tire or the wheel. You test it. It says there's a missing wheel. I mean, I don't know if we really can ever make a symptom for a wheel being missing. It's pretty obvious. Like your driver will be like, "Hey, there's a wheel missing." So I'm going to put this back on. We have an auto fasten mechanic.
I think long term the goal though is to build a symptom for virtually every part in the car. So there are basically no this is missing warnings.
How do you when you talk about the there's a knocking or there's some of those elements, is that just, your familiarity and your hobby with cars, or what resources do you lean into to make sure that they are accurately
correct-ish? Yeah, mostly it's just my resource, and then occasionally if I'm not sure, I'll Google or run it by some friends.
And this is something where Alec is the primary resource because I'm not a motorsports enthusiast. I mean, I enjoy cars and I like them, and I understand.
A lot.
I've learned quite a bit, and I love dynamics and simulation and physics and all that. So a lot of that goes hand in hand with race cars. But yeah, usually he's the one that makes up all the symptoms. But here's another example. I took off. Let's say I replaced the battery. There's this hold down you're supposed to put on there, which holds the battery safely in place. I'm going to take it off. I'm a bad mechanic. I forgot to put it back on there. We're going to put the hood back on, and I'm going to test it. And now I get the car is flagged for insecure battery installation, which this is kind of like a race check. So you go to a racetrack, the race officials there would look over your car and they would say, your battery's loose. That's a hazard. If it comes loose and hits your chassis, it could spark and cause a fire. So that's an example of a non-specific symptom where the player is expected to diagnose an issue. So they would go in here and look at the battery and say, oh, well, I forgot to put the hold down on. And so then they would grab their hold down, reinstall it, and I'm going to use the auto fasten for expediency. And we're going to put the hood back on, and then your symptom goes away. So that's just a quick example of how we generate symptoms in the game. And that goes hand in hand with the job system. And during races, you get symptoms. You can pit stop to fix them during these long races because we do have endurance races in the game.
Yeah, the races in the game run from a couple hours to I think the longest are 24. So, you're not going to keep a race car running 24 hours without some kind of maintenance. So the idea is, and we sort of compress time because obviously you can't have someone playing for 24 hours.
It's wow, really dedicated community members.
Yeah.
The race simulator is actually really interesting. It's hard to really convey that to people that didn't work on it because there's a lot of details that go into it, but it's something that is a very interesting part of our project. But one thing about the assemblies and how it relates to the race sim is that we boil down the whole car assembly into the parametric car that gets fed into our race simulator. So at one point, I wrote our custom race simulator, which it doesn't involve the player driving, and it's not a physically based simulation like in PhysX. It's just all custom code that runs, I guess, our custom car dynamic simulation for 10 race cars at a track. And we have parametric tracks based on a spline that Alec will create.
And to be clear, I mean, it has to run at like several hundred times speed, right? So if you're going to run 10 race cars at like 300x, you can't run a full physics sim. That just wouldn't be performant. And I think right now the sim, it does a lot of chassis dynamic stuff pretty well, weight transfer, grip.
Right.
Car.
So based on the car assembly, we look at every part that's installed, and I gather the mass properties of every part to compute the total mass and the weight balance on each tire. We have different springs you can install, so based on what springs you install, it affects the weight transfer for the race sim. We have sway bars that affect grip, basically. Different tires have different grip properties, and the condition of each part will have some factor in all that. Like you can also have parts like the turbo, which increase the horsepower, and also the body panels have aerodynamics configurations on them. So we tried to make the assembly matter. I mean, that's like the primary core of our game, and that was one part of a major update recently or last year.
I think we have a lot of plans for that too, like assembly quality and more chassis and engine tuning and shortening the feedback loop there so players who don't really know what they're doing can iterate and see quickly what's working and what's not. Right. That's a big direction for us for expansion.
Yes, and I'll show real quick in the editor kind of how we configure this because
do you want to show how much part data there is? Because I think that's it's kind of shocking how much config data there is per part.
I want to show the, I'll show that in just a second. I want to show an example of one part. So an engine block is pretty interesting in the game because it has a lot of things installed on it. So I'm going to pull up our engine block, and we use blueprints to configure all this, and these are actually the actors that spawn in the game. At some point, I'm probably going to optimize this for various reasons, but this is our engine block right here, and it has all these components on it for the different parts that can get installed on the engine block. I don't know how many that is, but it's it's a lot. So every bolt, every bearing, you have oil squirters and all this stuff, and they're all placed where these parts go. And each socket, so these are a component that we've created, snap socket. Each socket has a type, and that determines what parts can get installed there. So for example, if I look at the head casting, which has a strange location, but it has this part type class BPPT head casting. There's also some symptoms here, and we have these definitions called install and removal prerequisites, which control when the part can be installed or removed. Because if you put a part on and you bolt it down, we can't let the player remove that part until they remove all the bolts.
It has to be.
And so these are
because we don't do like a master object. We don't do like a parent object that knows everything that's there and rigidly decides the rules. Like the rules are, yeah.
Right. So the head casting, basically, it says that you can't remove it if any of these other sockets are filled and fastened. So head bolts are all here too. And then, so head casting is the part type. So if I load up the head casting, cylinder head parts, part head casting. And here on our part object, somewhere, we'll have the type. Right. So here we have the part type for this part. This is the head casting. It sits on top of the engine block. It houses the valve train the camshafts and that sort of thing. And so at some point when you're trying to install objects, it compares the socket part type with the part type. And if they match, then it can maybe start and install if all the prerequisites are met. And here's another example. This head casting has a lot of sockets as well.
Probably more.
Yeah, it's a lot. It's got 16 valves and 16 HLAs and 16.
The community was commenting that they would like to be able to purchase your socketing system.
We've talked about that, but it would take some work to make it generically useful to other people, I think. We put a lot of work into it, and that was the main thing I had to work on when I first joined the project. Is like, Alec has this prototype where a few things work, but he needed it to work for a whole car, and so
Or like be able to spawn
sat
an assembly.
down.
The game can't just be like a loose parts game. Stuff like that.
Right. I mean, there's a lot of stuff that goes on behind the hoods that we don't have time to talk about. It's interesting. Some instant static mesh components here. I use these to combine things. So if you install one of these, like say a valve, and they're all the same mesh, I detect that, and if I have an instant static mesh component on the part, then I'll merge those into a static mesh and set the transforms up. So we can really save a lot of draw calls, because there's almost 1,000 parts on a full car, which is basically like, our game is interesting because you think of our car as a level. It's like, most games have a level with a lot of stuff in it. We have one car assembly. It's basically like a level in a game. It kind of makes you feel better about not having a lot of space when you think about our game like that. Sometimes
It's very
think that our game is too
typical.
small.
Like a lot of content crammed into a small room.
Right, and so that's just a very basic overview of the part system. But a lot of that gets stripped out by some editor tools or some other systems I have, and we put it in data tables because I want to be able to access a lot of the part information without having to load the parts, because we have, I think, somewhere between 350 and 400 different parts in the game right now. Those are unique parts. Now, on the actual car, like I said, there's maybe 900 instances of parts, but I can't have those all loaded at the same time. Also, for future proofing, if we want to have a lot more assemblies, different car chassis, maybe support for mods, I definitely can't have everyone's data loaded all the time. But I want to have access to the information so that I can manipulate assemblies in C++ without having to load the parts. So we have our master part data table. This is a very massive data table. It basically has all the information that you can figure on a part. So all those sockets you saw, if I find the...
And there are a lot of parameters
Engine
on the
block.
sockets too. It's like...
Right. So here's the engine block. I found the row. And we extracted all the data here. And there's soft references to things like if I want to actually load this class so I can spawn it, I have the actor class right here. So if somewhere in code, I have this part ID, I can find this data for it. I can create an instance of this actor. I can install stuff on it. But here is the list of all the sockets. So that one, the engine block has 109 sockets on it. That's where things get installed. And each socket, let's pick one at random, oil squirter bolt. So each socket has a transform that I need to do things. It has the part type class to help figure out which parts can be installed there. All these prerequisites. We have symptoms here. These are our simple symptoms. So if like a socket doesn't have something installed in it, then we report symptoms using this simple system. Symptom for loose bolts. We don't use the rattle symptom yet.
A couple times we do.
These are sort of some... What's
We
that?
use it a couple places.
The rattle symptom? I
I don't know.
We have torque information, so every bolt in the game has torque specifications, and we don't do enough with that yet, but for the jobs we do check the target torque specification. So if you miss torque bolts during a customer job, then you get penalized. And we need to do more of that in the race simulator. But it's a lot of
toward
data that goes into
Natural
this.
consequences too. I mean, we have all this data, and it's like to make it.
Most of these, so he should get an award for data entry.
Yeah, it's time consuming.
Yeah. I want to say something too about our part system. There are a lot of actors on one car, and there's a lot of components. I had to profile it at one point because you do get like a hitch right now when you spawn a whole car, and it's something I'll look into fixing over time. But we have, around 900 actors and something like 7,000 components, maybe more than that. And it's just a lot of code to chew through to spawn all that stuff, including some of my blueprint setup code. Once that gets moved to C++ with some other optimizations, I hope to fix most of that. It doesn't happen too often because you don't load and unload cars that often. But it's worth mentioning that, if you do use a ton of components and a lot of actors, it can add up for sure. Any questions about the assembly system
Let's see.
or anything really?
So, is the assembly system mostly your own custom code then that you built in the backend, or?
Yeah, it's all custom code. And originally, the entire assembly system was in blueprints. I mean, it hasn't changed a whole lot since we started doing C++, but over time, sometimes when I'm reworking a system, I get the itch to move some code to C++ because sometimes if you do technical or math heavy code in Blueprint, it can just get visually large and hard to understand. And a lot of times I'll write helper functions in C++ that are just static functions that take a few parameters just to help make the Blueprint code that still exists a little more readable. But yeah, all of the assembly code is 100% custom for Wrench. We actually don't use any third-party code plugins.
We use a handful of third-party environment prop assets, literally a handful, and that's it. Everything else is made for Wrench.
Yes. All right. So I think another big topic that is kind of unique to Wrench, and I'm sure it affects some other games too, is physics. Actually, every game probably that has physics in it has annoying bugs and problematic cases.
I think we've invented the worst case game though for physics because it's nested, concave, varying sized actors of all kinds of different masses, literally installed into each other in big chains.
And it's important to mention though that when we first launched Wrench, we didn't have any physics. We didn't even have gravity when we launched it. You would
I thought it was a really bad idea.
Car, and then you'd let it go, and the parts would just float in midair, which is kind of useful sometimes.
Yeah, well, I think the initial thought was in VR, I don't want people bending down to pick stuff up. I don't want to be pick up stuff off the floor simulator. But distance grab and a few other things, I don't know how to alleviate that. But
so we quickly added gravity. I think it was in the first few days, just because I think people were annoyed that the parts didn't move after you released them, which is understandable. But the parts didn't collide with each other initially because that was going to be a big can of worms. And we didn't really know how big of a can of worms it would be. I remember telling Alec, hey, Alec, maybe we should add physics to the game. I think it'll be easy. Just give me a few days. And then 2 months later, I'm like 2 months. Alec, I think it's ready. That was a lot. And I'm going to load up VR again just to demonstrate in the game why physics are challenging for Wrench. And I'll try to describe some of our solutions to it. It's a little bit detailed, but if I load it up in VR, we should see practically why there are some issues.
I think pretty much any developer who's worked with real-time physics and odd-shaped physics bodies and trying to get things to behave nicely, can understand that it's a pretty challenging scenario to try to get that to work in.
See here. Controllers.
The other thing too is we run the physics in desktop and VR, and I think we're going to make some changes with desktop and how they work. But it's a challenge because we have people set up these sort of complicated workspaces where their parts would be all nicely laid out. And then like they grab something and just like knock a bunch of stuff over. We're always trying to like reduce the amount people bowl their stuff over with another part. So trying to make it so like it used to be every time you distance grab something, it would like fly towards you. And now I think we've changed the threshold on that because like when things fly towards you, they knock stuff over. Lots of
Maybe
stuff that you wouldn't
something
think of
where, like,
initially.
It doesn't have collision or something, like if you do a distance grab, so that way it actually wouldn't hit anything on its way to you.
Yeah, I think we've thought about that. We don't do that right now though. I think we've just really made it, especially desktop. Desktop used to when you pick stuff up, it would frame up and center on the screen.
Mhm.
And that was terrible because you couldn't pick something into desktop without knocking stuff nearby over. So now we have a very simple, like when you pick stuff up, it stays in space where it was, and you can sort of more carefully move it around. It's less
Right.
awkward.
So here, I want to show off a few things in VR, just because VR is kind of handy. Actually, let me get rid of this stuff here. All right. So in VR, we have like pockets on our hands, which is another solution we have that we're not going to really talk about, but you know, we conceptually have little magnetic pockets on our hands that let you have small parts. But like, so when you install things in our game, they're actually going into the collision of other parts. So if I drop the bolt, you know, it sits on top of these other parts. There's physics interactions there. I can put it and catch it. But when you install it, it goes in. And so there's a transition period here where you approach it and it starts to install. That's when we disable physics, go to the like an inverse, not inverse kinematics, but a custom animation. It's not animation, it's a procedural animation when we install the part. And it feels like there's like some physical interaction when it's sliding in. Alec was talking about that earlier. But there's a lot of details to keep the physics working and have the parts install nicely. And that kind of goes for everything. So you got these parts too, and they kind of clip through other parts. That's kind of unavoidable. And that's
We have
one of
the
the many
rule for uninstalls because that was a big thing initially. Like we set up physics, and I had to go over the entire assembly and find out like which parts can't you install right now. And it was like a third of the parts just physically couldn't be installed, either in desktop or VR. I had to figure out all the parameters to get each one to work.
Right, because if you couldn't get the part close enough to the socket because of
Right.
actual physics interactions, it would never turn off the physics to allow
a
it
little
to
bit of a
start
game
to
of
install.
tweaking collision volumes and tweaking install parameters.
So another interesting thing I want to show about our physics is that this assembly right here is a lot of parts. I don't know the exact count on the engine, but you know, it's
a couple
a
hundred.
large quantity of our car parts. It's probably 400 or something. There's a lot of things here. And I'm going to detach it from the engine stand. It falls down. We do have a gantry crane in the game that allows you to support the engine block, but it's very heavy. And so you'll notice here, like, if I drop it, it hits on this manifold part. It doesn't go through the ground. It kind of stands up on that. And so if I uninstall that part, which I can do with auto unfasten quickly, take that off. It's its own physics object now. And now, you know, there's no physics there. So we needed these complex, you know, hundreds of actors assemblies to operate as one physics object. And that was a big challenge to get working correctly.
Including like their
UE4
masses and stuff too, not just the
right.
collision shape.
Yes. Yeah, you can see here, this is a heavy object, and I actually can't quite hold it up with one hand because the way the virtual reality grabbing parts works, it's using PhysX constraints. If I grab with two hands, I can hold it better because there's now two constraints. So we're actually a little bit too strong. The player probably shouldn't be able to pick this up so easily.
Yeah, we've talked about that. The players are very strong.
So if I uninstall that, then it's a smaller physics object. So it's just the physics part was very complicated, and I'm going to get out of VR now so I can talk a little better. There we go.
So each of the parts, then you've also included mass. So it's like,
Yeah, and we
are
do a
they
mix.
affect how you actually interact with those pieces?
They do. So we do a mix of auto-generated masses, and then I mean, there's a scale back there on my office. I've weighed a lot of stuff, and we do data entry. So I sort of go through and I say oh, that's really wrong. Just looking at it, and if it's wrong and heavy, I definitely get the real mass and fix it. If it's wrong and we're talking about difference between 3 grams and 6 grams, I don't care. It doesn't really matter. But yeah.
Right. Now, I think, I was talking about how there's so many parts back together and they operate as one physics assembly. UE4, in PhysX, you can weld physics bodies together, and that's how it works. But in order for that to work in our game, it took a lot of custom code because our parts aren't directly attached to the root physics mesh of the assembly. They are attached through these socket components, which kind of breaks the default logic of the physics welding system. So we have a system where when you install a part onto an assembly, it disables the collision on the actual part and it creates another fake invisible component there just for physics that attaches directly to the root. And another important part is we ignore that extra physics on a lot of the parts. So all those small bolts that get installed, there's a threshold, and if it's smaller than 5 centimeter radius or something, we don't enable the physics when it's installed on an assembly. So we wouldn't have 400 physics objects all attached on one welded thing. It's probably more like 20, which is a lot for one thing, but the engine is one of our complicated assemblies, so it works out pretty well. And there's a lot of collision mask shenanigans and other things that go on to make all this work. And if there's, if people are interested in knowing more, I can try to talk about it, but I think it might not be interesting to go through all the details of that specifically.
Move on to art workflow stuff if you want, Jim.
Yeah, I think so. Unless there's any
questions
to take.
Let's see. Well, the latest one is the center of mass taken into account for physics.
Yes. For what? I guess we have a lot of different systems that might care. I mean, by default, the UE4 and PhysX collision masses have a center of mass, and it's recorded, and whenever you grab something, the actors aren't always positioned at the center of mass, so it's depending on however Alec authored the artwork pieces. Sometimes the actual actor center is at the bottom of a part and the center of mass is in the middle. And I don't think there's a whole lot we need to do for that when we're grabbing things, because it just mostly works through PhysX, because we're using constraints when we're grabbing it. And I mean, it took a lot of tweaking to get the grabbing constraints to work pretty well.
And there's still some room for, I don't know. I think we're going to keep tweaking that for a while. There's occasional problem parts or things behave.
I think the only case where I have to worry about the center of mass a lot specifically is, I think, grabbing in desktop mode. I actually position the grab at the center of mass, because if I don't, in the physical constraint, the part might drift
go
because of torque. There's a lot of little details that make it hard to get this stuff right. You just have to work through it. And then for the race simulator, I look at the center of mass for every part when I'm calculating the full assembly mass and the weight distribution. So I use it for that as well.
Nice.
So Alec, I guess you can. Oh, is there another question?
No, I was going to say, they do have lots of questions about the art pipeline and how you generate the assets. So
Okay. I'll jump into that then. So I'm going to share some images. So first off, one thing that's uniquely challenging about this is we're building a bunch of parts that actually need to fit together, or they need to fit together within a margin of, a millimeter or so. They need to visually fit when they're actually taken apart. Whereas normally when you build a mechanical assembly for a car, for film or games, it just needs to look kind of right from the outside, and no one really cares what the inside looks like. And a lot of stuff gets simplified. So yeah, problem number one is everything needs to be dimensionally accurate. And there's sort of two ways you could approach building things fit together. You could decide, I want to build a block out model of the entire car I'm going to locate every bolt hole, every locating surface, and have it all clearly defined first. But the problem there is we want to do aftermarket assemblies. I don't want to do that blockout model because it's a ton of work, and stuff's still going to be wrong. So you're going to run into issues when you go to put an aftermarket part on, it doesn't fit. You have to adjust those dimensions, and it's pretty easy to make one error in one place and have that propagate down the chain. So this is an example part, is a front upright. And there's just, every one of these dimensions is important. The bolt hole locations, all of these bolt holes are off axis. They're not simply defined on like XYZ. Just a lot of places where a bunch of stuff's nested together. And if one thing's wrong, the next part's wrong, and the next part's wrong. So I use a 3D scanning workflow to at least get dimensions for almost everything in the game. There's some things that I've made up, and some things that I know don't have downstream dependencies. I just kind of ballpark. But either I 3D scan or I have calipers on my desk, and I sit down and I measure what I need to. So as part of scanning, what's interesting is, we have to inventory and keep all the parts. So like step one is tear down. I tear things down. I organize them. I end up making a little labeled bag so I know where things go, which is this kind of thing you do generally when you take a car apart, especially if you're going to take a whole car apart. It's not just like a one-day job. You have to track what you've done. So this is a whole first step before I can build anything. And then the actual scan process, I just have a DSLR and a couple of lights, and the lights are pretty key to be able to handhold. And it's a process of cleaning the parts because they're all usually oily and gross. So pressure wash, degrease, pressure wash over and over again. And then prepping the surfaces. So this is a Contesco developer spreadsheet for detecting cracks and welds. And you give it kind of an uneven coat, so you get a speckly surface. And then I run, you can see at the bottom here, a little bit of it. There's a machinist ruler that stays in the scene. And then inevitably, for a lot of the heavy parts, like I think this block itself is 85 pounds. I don't want it moving, so I can't hang it from a string. So I made a little fixture to attach it to. And these need to be strong enough that I feel like safe climbing under them with them over my face. And I think this scan was maybe 800 photos, something like that. And so they end up with this raw scan, which looks really cool. Reality capture is fantastic. And you can see I've done a few things ahead of time, like I painter's taped the deck, and I cut little cardboard circles to fill in the pistons. And that's because the workflow I use for stuff like this, especially cast parts like this, is I'll get the scan data, which is great on all the rough surfaces. You get all this cool casting detail, but the machine surfaces are super noisy and look bad. So I'll go in and I'll remodel and clean up all the polished and machine surfaces. So you end up with this as a final result for the high res. And so what's pretty cool about this is it's not so much work to get to this step on the high res, and this is a super detailed high poly model. There's some processing time, but I usually run that overnight. And so as a workflow, this part's pretty quick. The challenge now is this is really hard to make a low poly mesh from. And you can't simplify details and have them project well in your bake like you would if you were building a high poly mesh like this from scratch. You might make some concessions about some of the surface detail that the player will never notice, but it'll just make the silhouette simpler, make it easier to bake, speed up production, but you can't do that. So the low-res process is really time-consuming. I do a mix of different things. I think this one's actually a decimated scan for the low, that I then go in and manually clean up all the geometry for the bolt holes, make things round, the piston bores are cleaned up, stuff like that. But yeah, so it's interesting because scanning, on the one hand, it saves you a bunch of time on the front end building the high, but on the back end of building the low res and doing the UVs, because there's no topology to follow for UVs, it actually doesn't necessarily involve a net savings. Then you add in the fact that you're like inventorying and cleaning and disassembling. Like it's a laborious process to build this content. Let's see. So after scan process, oh, and I guess another thing I want to mention is, the way I approach this, the reason I don't do a big block-up mesh is I like working on everything independently as an isolated object. And the idea is like every part in the game is a hero prop. It doesn't matter if it's like some bolts or a control arm, like everything should get the same level of effort and attention because the player interacts with every part up close. It's not like they don't see certain things, they see everything. So everything is a priority.
So how long, they're asking, like, obviously it's going to depend on the part, but like how long does it take to clean up some of those methods?
It's really variable. I mean, like I've had, like the most complicated part of the game is probably the cylinder head casting. And building the low for that, I think it was 2 full-time weeks of cleanup and UVs and just it's a nightmare. That's the worst case scenario. Sometimes you get parts like these gloves. I scanned. This is the raw scan of these gloves. I was like, I need some VR hands. 24 hours later, I had these in game from when I scanned them. It was like super simple. This was such a huge time win that it was like, okay, I see why this is good. Yeah, so it's really dependent object to object. And some objects I only use the scan for dimensions because I can tell like I want good topology for this low. There's no way I'm going to retopo process this. I want to build it from scratch. So I just know I'm going to get a rough scan for dimensions. I can verify some things with calipers and go from there. But a lot of I would say it's probably 50% of the high res geometry in the game by surface area is from scan. Yeah, and then so the process from there, I mean, we use our own baking tool. Jim talked about earlier. We have a tool called Handplane Baker, and it's free. But I like it, obviously, because I help design how it works. So for me, it's the perfect baking tool. And it handles really high poly mesh as well, which is good because some of these meshes get very dense because the scan data I crunch down to usually 10 million parts or 10 million triangles per part. But if there's multiple components, they can get huge. So yeah, here's an example of a raw scan. And then the materials workflow. One of the things we do with the scanning, I actually should mention earlier, is I don't attempt to scan materials. We treat every surface. The materials pipeline is actually really easy. It's like kind of the lowest effort part of this whole art process. And that's because there's so much surface texture and micro detail to pick up on cavity maps and curvature maps that the extra hassle of attempting to scan materials and the loss of quality you'd get on the scan for this stuff just doesn't make any sense. So I've got one of our materials loaded up for this, and they're just really simple. It's just solid colors. Yeah, smart masks. This material probably took me 35 minutes, 40 minutes. And I have like a library I've made of smart materials for like cast aluminum or like stamped steel at this point. So I just drop them down. I tweak the dirt levels and maybe paint in some masking here and there. But it is fast. And then, yeah, I guess the biggest thing is that scan versus sculpt difference. So as I said, about half the parts are just sculpted, half are scanned. Mostly you can't tell them apart. I put a lot of effort into sculpting the same kind of details, weld spatter and welds and casting details. But yeah, really everything's just done on an individual basis and what seems like the most time efficient. And sometimes it clear like I made the wrong choice, but I've committed. I think I did the alternator recently, and that was a from scratch sub-D model, and it turns out that just has a really complicated surface area, and I would have been better off taking a different approach, but you sort of commit at a certain point. Yeah, and I think this transitions pretty well into like how our lighting and rendering works. So our game is all these hyper detailed parts. As Jim mentioned, there's roughly 1,000 actors in the game jammed together. And we're a VR game. We're also desktop. Now, traditionally, people would say VR game, you should be in forward rendering, which makes dynamic shadows expensive. And part of the issue with that is if you don't have dynamic shadowing, you don't have dynamic occlusion, you've got all these dark, shiny surfaces crammed together, and the appearance is when they're on assembly that everything glows. There's just too much unoccluded indirect light, too much unoccluded reflection. So the initial solution that was just to make the lighting very high contrast. So there's just very little fill light. And this looks great some of the time when you've got the sun hitting something and you've got direct light showing. But a lot of the time it's really dark, and you can even still see like there's odd amounts of indirect light and reflection on things. But we had a lot of users complain the game's too dark. I look at some of those older builds, it clearly was too dark. So the solution to that has been just to really lean on AO. And SSAO has its limitations. But yeah, let me see if I can load up the editor. The other thing I've been working on lately, actually, is we've been working with NVIDIA to integrate ray tracing, which it's kind of the perfect use case for ray tracing. We've got all these dynamic parts. They're shiny, so the reflections show up, and you get just this like really nice, very directional indirect that you couldn't get otherwise, and it really ties things together nicely.
Yeah.
Yeah, and it's pretty cool. Especially at lower resolutions, ray tracing is actually pretty performant in our game. I've had been able to run like 60, 70 frames per second pretty easily.
Yeah, that looks really nice.
Are there any questions on the sort of art pipeline in general?
You touched on it. So you said you were using reality capture to get your scans. And then it sounds like when possible or when it makes sense, you're using the scans to actually capture real parts. I imagine if there are parts you don't have, is that when you would also go about modeling them, or do you have full color parts that you've broken down and just like the whole vehicle is available to you and you're taking it apart? Or
more or less the whole vehicle. There are some things where I've like borrowed parts. In general, there's some parts I make up, like this air filter. I just made it up. I know what an air filter looks like. I know what the dimensions need to be. But yeah, in general, if it's on the car, it either came from a manufacturer that had CAD, so like these control arms, the bottom, these red control arms, that manufacturer has CAD data and pictures, so I was able to work from that. But yeah, in
so that
general,
one, you did not scan that one, though, I think. Not everything is scanned.
Not everything is scanned, no. But of like the OEM type base model parts in the car, almost everything got a scan, at least to pull dimensions from. Like a bolt, I don't scan. I have thread pitch measuring tools and calipers, and I just look at the dimensions. But yeah, in general, everything gets a scan. So it's a lot of work.
Yeah.
All right, Alec, you done with that? I think I can talk a little bit about how we support desktop and VR in one build.
Yeah.
Be good. Yeah, so like I said at the beginning, that Wrench was originally developed, let's say VR first, and we added desktop later. And so it has the bones of a VR game. And, VR development, I think, is still kind of new. It's still getting figured out. Some of the primary solutions are becoming apparent, but here's a picture I'm loading up that has all of the, I guess, current VR controllers. You got the Oculus Touch controllers, Valve Index controllers. There's a HTC Vive controller, WMR, which is Windows Mixed Reality, HTC Vive Cosmos right here, and another
has its own controller also.
Right, I think this is the Reverb 2 G2 up here. And the reason I pull all these up is because the design has not consolidated yet, say like a gamepad design. A lot of them do have 2 buttons and a joystick, but a lot of them also have like a trackpad and no joystick, and the grip buttons are slightly different. So the ergonomics of all these controllers are different, and that really has an impact on your input system and how you can make things play well in your game.
More or less constrained by, we want to have a unified input system for all the VR controllers. We don't want to change the way interactions work between controllers. So it's like the controller with the least inputs constrains what you can do on the other controllers.
Right, like the HTC Vive controller, which is one of the older VR controllers. It doesn't have a thumbstick, and a thumbstick is a great way to get around in VR for teleporting, for smooth locomotion. There's great uses for it. And when you don't have that and you don't have extra buttons, you're very limited. It forces you to make almost all the interactions in the game physical, which sounds good for a virtual reality experience, but when it comes down to it, buttons and thumbsticks are still a very good input device, even in virtual reality. And devices are still clunky. So if you're playing in VR, you have some VR controllers. They're not the size of your hand. They're bigger. So if you need to do something very precise, close together, your controllers hit. And that can be a problem for our game because we do have a lot of small parts. So we have to be aware of that and design things while also maintaining functionality in desktop. So I guess we've gone through several iterations of input systems. For example, for the tools, we originally tried to use the buttons to change the settings on the tools. For example, the torque settings and whether or not you're in fasten mode or unfasten mode. And then I think we were trying to improved the support for Vive, and it didn't have these buttons. And we had to figure out the solution for that. And I'm going to load up VR real quick again, just to show.
It is at least
handle
one of
that
the
in
nice
VR.
things, even though we have to do support for each new controller. There's been some convergence on like what a VR controller should have. They have kind of the same stuff on them at this point. I mean, there's always oddballs, like Index has its own grip system, but yeah, usually you get a thumbstick and some buttons, a grip button and a trigger.
Right, so here is our one of our wrenches in the game. This is the breaker bar. It's a pretty big wrench for handling large torques, and we used to have the settings on the thumbstick or the buttons to change things, but we couldn't do that on the Vive, so we had to go to this virtual button system. So as you get close, empty my pocket again. So don't need those bolts in the way. As you get close, we change the pose of the finger to the pose of the hand to a pointer, and you touch these little virtual buttons, and that changes the settings. So we can increase the torque setting on this wrench. We can change it from fasten mode to unfasten mode. We can install the socket extension. Eventually that'll probably be a slide-on extension, but for now it's just a button. And so this is just a solution that we had to come up with to accommodate all the different types of virtual reality controllers.
I think especially too, when
And-
we first started, there were so few. Like when Wrench was first in development, VR was new enough. There were no real conventions for even locomotion, like how you should use smooth locomote. You know, there were some games doing smooth locomotion, but it was like there wasn't even a consistent style or input. So yeah, we've definitely looked at other games at this point. Like we decided to move teleport to down thumbstick because people were used to Half-Life Alyx, and we're like, well, we have that input. If people are used to it, if it's a convention now, we're just going to do it. But when we started, that wasn't a thing. So I don't know. It's been interesting.
Right. Originally, we had a toggle mode between smooth locomotion and teleport locomotion, and I was never quite happy with it. But I think there was concerns about people getting nauseated while playing VR, so smooth locomotion wasn't what everyone wanted. But now we have both available at the same time, and it works out pretty well. So for the tools, I want to pull up the wrench real quick in the editor, just to show practically, how it works in Blueprint land. And again, all this stuff is still in Blueprint. Maybe some helper functions that do some things, but our ratcheting wrench, I like to think about our wrenches as like a character in the game because it's a very complicated thing. So we do all the torque settings and the smooth torquing of the wrenches with good haptic feedback. There's a lot of haptic feedback in VR. If you don't do that, oftentimes the VR experience doesn't connect with the player because you don't touch things in VR. You're holding a controller, but you're seeing something. So when you have haptics, it's kind of a replacement for the tactile feedback of a real object.
And also effort. It's hard to simulate. Like when you pull on a wrench in real life, roughly like I'm pulling this hard. It's not about position; it's about force output. But you don't have that in VR, so it's been a way to give people a sense for that, where they can sort of feel what they're doing.
So you sort of like ramp up the vibration or
Yeah.
whatever, depending on how we did that a little bit in Funhouse on the VR
Yeah,
Funhouse. Like
I
if you
think
pull
there's
the bow back, the further you pull it, the more it would just shake as you pulled.
Yeah, the
it's kinda
vibration ramps up, and then also the hand distance increases. Because Jim, you could say how this works better,
I'm
but the
pulling
hand
it
is
up right
exerting
now.
a force, and then
Just-
it's all calculated at the bolt. The actual torque calculations, like per rotation, are pretty accurate. Like I have a calculation tool for you define the joint and you give it the thread pitch, and it'll give you like how many torques per degree of movement, and that all gets entered as like a data table.
Yeah, and so for the wrench, when we're doing the grabbing, pull force, and all that, we have configuration for each wrench because we do have a few wrench sizes, and in order to make them all feel natural, we have to have different settings for those. So we have like a pull coefficient that essentially takes the offset from your hand to the grab location on the handle, and then it converts that to a force in newtons, and based on the length of the arm of the wrench, and it converts that to a torque that applies to the bolt. It's there's a lot of code that makes it happen. There's even something here I have called gentle torque coefficient, because there's a lot of things you don't get in VR that you get in real life. Like as you're pulling a bolt in real life or anything that involves force, you have a lot of feedback from the physical contact with your hand.
Right.
So you can be gentle and strong at the same time.
And you can
replicating
spread that feedback out over time. Like you can't, it's not, before we did that,
Right,
it was so instantaneous. It was like, oh, I accidentally exerted, 200 meters of force suddenly. Like it was.
You can immediately turn off your muscles basically, but in VR it's a little bit harder to immediately stop pulling when it's based on a distance because the distance is still there. You can't teleport your hand immediately. So there's some details we figured out along the way. But here is just an example of an interface we use for grabbing. I call it Grabbable. I mean, it couldn't get more applicable than that. And in order to support holding and operating things in VR and desktop, you mainly have separate code paths for a lot of this. So it's not really easy. Some things do share some code, but
it's basically almost two games of input system working simultaneously.
Right. So my input update method for the wrench in screen mode, which is what I call desktop mode in code a lot, has a lot of different code paths in VR. All the tools work like this, so you grab them, and then based on if you're in virtual reality or screen mode, they get different interface calls. And then the tools also have use actions and a few different ways to adjust them that are all interface based. So we do have some common interfaces that allow us to talk to the tools. There's still a lot of custom code between desktop and VR. And here you can kind of see those virtual buttons on the ratchet, and those just get hidden when we're in desktop mode because you use keys to adjust the tools in desktop. I think there's one other thing that's interesting for desktop and VR, and that would be the user interface. We basically created like a tablet application system for Wrench. When you're making a user interface for VR, you quickly realize that you can't do anything like you can for a regular PC game, and it's also very different from a console game UI. I don't.
There's also a lot of.
It's very difficult actually.
There's also just totally different constraints on how densely you place interactions or information. Like font size need to be bigger, things you push on need to be big enough, and trying to style that in a way where it still looks good on desktop and in VR. I think the current one's pretty good. The initial one was like sort of temporary, but
right. I'll show it a little bit in the desktop game just to give people an idea of what it does.
And this is one of those times where like Jim and I don't do UI work, but now we do. It's part of indie dev. You just have to do stuff that you don't know how to do.
It's just the two of you, right?
Just the two of us.
Yeah, they were asking, and it's like, I'm pretty sure it's just you.
Yeah, I would say, pre-launch, I had a few friends do some contract artwork for me, but like maybe a couple hundred hours in the scheme of many thousands. So it's like, 95, 99% off, something like that.
And so we call this Wrench OS, which, it's kind of an app-driven system. So each of these different apps are individual widgets that we have, and there's a configuration table where we can add and remove these, and they show up at different times. So if you don't have the ability to go to a race yet, or if you don't have the ability in the game, or if you haven't unlocked it to buy classified cars, that app is hidden from you. So it kind of expands as the game goes. But each of these implements an interface that the base Wrench operating system communicates through. So we have unified back support, kind of like a phone. It's really based off of a phone or a tablet. So it was interesting to create that type of a fake operating system application system for the game. So here's an example of our catalog where you can buy all kinds of parts. We have an on-screen keyboard which works in VR. Well, this isn't VR, but in VR, if you click that, it'll bring up an on-screen keyboard so you can filter parts. Like bolt. Oh, look, here's all the bolts.
All the bolts that are named Bolt.
All the bolts that are named bolts. That's right.
Plenty that aren't.
Yes, and then the logbook. Oh, yes, I can bring up the logbook for a car because this is one of the... Oh, I don't have any parts inspected.
It's like a gameplay tool
Put it on the.
that we use to let the players track. So parts fail based off of age. So once they reach their intended service lifespan, they have an increasing chance to have a mechanical failure. So parts don't fail immediately when they get old. They just have an increasing chance to. So the idea is you're supposed to replace parts before that, and ideally before that enough so they don't fail during a race, because you've got to put hours on it while it's running.
As you
So
see here,
yeah, it's a tool for them to track like how old the parts are.
I'm
when they
walking
last
around the
serviced.
car, visually inspecting it, and the game does a lot of raycasts while you're moving around, and it will see what you see, and it tags them and adds them to your internal logbook. So I just loaded this car in the lift, and now my logbook is populated with things. Now I didn't fully inspect them, so it doesn't know what the wear is for all these. I actually have to look at it for longer.
And that's actually something I think we still need to do a slightly better job communicating to our users. Is age is not the same as condition, right? Like age is a indicator for you to figure out condition, but like a part can be old and not failed, and under certain circumstances, a part can be relatively new and have been failed if something happened. Like they're usually closely correlated, but occasionally they're not.
Right.
Do we still have that on there where it says race hours do not equal condition, like printed on the top of the logbook? I think one of the
I
early
think we
versions
removed that because it
had a
was
big
bad,
warning.
bad
Yeah.
user interface design.
Yeah.
Teach that. There's a help app. We do actually have a help guide in here which tells you things about the game. Logbook. So here we talk about that. So anything we don't explain in the intro tutorials, we have some basic help topics for that get unlocked throughout the game, and they have information on the different systems we didn't want to force the player to learn in the tutorial. And these are still in development. We need to put images in them, but the framework is there. This is also where we have service guides. So for like this Catfish chassis, we have different guides for uninstalling.
And
all the
that's been a whole thing
parts.
too, because it's like a dynamically interactive tutorial, right? It's a tutorial, but you didn't spawn the actors. You don't know what's in the level, so it's like finds the related root objects in the level, finds like the closest route that's relevant, and then like can highlight things in the world. But it has to make a bunch of assumptions so that it's not this like highly structured. Okay, I'm going to load a tutorial now. You can sort of apply the tutorial to what you're working on in the middle of your assembly.
Right. This helps player learn how the assembly of an actual car might work. And they can follow through with our highlighting system. But the user interface, this is the same like in VR and desktop. We did not want to make different user interface because it's a lot of work to make UI for a game. And so the tablet in VR is just projected onto an object, and then we use the VR hand as basically a mouse pointer to touch different things and interact with it. The only thing we had to keep in mind, and you can tell it here, is that the buttons are larger than a typical desktop application. And that's the same rule you'd have for a tablet application like an iPad or Android tablet. You need your buttons to be big enough to where someone can finger touch them. And that's especially true in VR where the fidelity is not quite as high as a real fingertip. So we have to keep our UI big enough to accommodate that, while also not too big to feel terrible in desktop mode.
And on the not making separate UIs, it's not just two UIs. We have to teach people how to use two UIs and interact twice. And we have a non-trivial number of users who switch between desktop and VR. So like if you're used to it and you change modes, it's just confusing and distracting. So yeah, I think everywhere we can with VR and desktop, we try to converge. There's lots of areas we just can't, but yeah.
Yep.
Ranked up like 1.5 games, not quite 2 games.
Here, I'll boot up the UI in VR just so you can see it.
Direct comparison.
And interesting too, like VR is highly marketable, and this is a really cool application for VR. It's very spatial. VR works great for Wrench, but it is, I think, 60 to 70% of our user base is in desktop mode, just because gaming PCs, there's way more of them than VR headsets. So sometimes it feels like a lot of work to maintain both, but I think they both have a lot of value for us.
Yeah,
I'm
'cause
gonna
that
load
feels
my
very
car back
similar.
up here so that I can inspect it again, and you'll see as I walk around. I didn't save that other game in desktop. It would have shown up here. But as you look at parts, they flash. Inspected and get added to the logbook. So I just inspected a few parts, so we're gonna go our logbook, and now we're here, and we can actually swipe the UI with your finger here. You can touch it
Just to trigger it.
with your fingertip, or you can get close enough, and we have a little laser pointer. You can select things that way. Because a lot of people might misclick if they actually have to move their controller to do that.
Yeah, I like the trigger. That's what I do. But it's good to have both. We do.
Trigger
There's
works.
a lot of parts of the
works great.
game where it's like, even just desktop, picking stuff up, you click to pick it up, click to drop it, or are you gonna hold it and release it? Like, there's lots of parts of the game where there's like multiple ways you can do it, and it's because like people will intuitively try differently, person to person, and if you know what they want to do, just let them do it.
Be careful, you're hitting your mic a little bit there, Jim.
Yeah.
Oh, sorry. I can't see. There we go. So here's just an example of how we deliver parts in the game too. This was a packing system that we recently wrote, and you can order a bunch of parts, and our game figures out how to pack them. I guess one part didn't fit in that other box. And you can grab them out of the box. You can dump the box out.
It used to spawn them suddenly, but it was like opening a pinata.
They just like appeared.
Well, because they couldn't physically fit in the box. They were just like,
Oh.
so they were smaller, or conceptually spawned at one location and spread out, and then they would appear and then enable physics and then just explode. Which, when you have a game where the players are ordering like small parts in quantities of like 100 or something, it's not great to have them have to go like find them all afterwards. So this is actually a relatively new addition. I think this is one of the last really like problematic things we resolved in the game.
All right.
Jim, do you want to just take questions now if there's questions?
Yeah, I think that's pretty much all the stuff we wanted to go through.
All right. Yeah.
Back in the real world.
Welcome. They're wondering, with VR performance and optimization, where did you all find yourself starting when sometimes you were trying to troubleshoot if you were encountering difficulties?
Yeah, I would say, so we're on deferred and we do dynamic shadows. And
Mhm.
those are two things you're probably not supposed to do in VR. So we've had a bunch of solutions to improve things, and we have a lot of objects. It's like 1,000 actors that's with materials. It's thousands of draw calls just from the get-go.
That's important to note that in VR you've got two eyes, so you basically double the draw calls.
Right. So we do a couple things. Dynamic shadows are one super high-res cascade. We don't do multiple cascades because at that threshold it multiplies the draw call count. So it's the garage is a certain size. The shadow distance in the garage is the furthest distance between 2 points in the garage. So you're always within the shadow range, but it's tuned for that. And I think at our highest res, Jim, is it still 8K, the highest res shadow map?
I don't know, probably. I think it's
huge. But it's like we have memory to spare. That's the least important cost. And then we also disabled early Z-Pass, and that I think cuts our draw call and triangle count in half. So that was large for us.
just limits a few features, that's all.
Yeah, we can't use G-buffer decals. I think that's one of the ones we can't do.
Right.
But
I mean, generally to optimize, we would use just like the stat scene rendering, stat RHI, and just look at the total number of draw calls. Before we even launched the first version, I worked on using the instance static mesh components to aggregate.
Yeah, because our first launch, Unreal, I think 4.16 added a dynamic instancing system for repeated actors. And this was before that. So Jim wrote a custom installed mesh instancing system. So if multiple parts of the same type were installed on a route together, while installed, they could be instanced.
Right. So
yeah.
For the example, a good example would be on the cylinder head, which has a lot of duplicate parts. It has 16 valves, 16 HLA, 16 springs, and so whenever those parts get installed on that, we have a flag on a part that says, I want to try an instance when I get installed. And if that flag is checked, it will ask the parent part, it's like, hey, can you instance me? And it'll check to see if it has an instance static mesh component ready to accept that mesh. And if it doesn't, it'll add it into a new slot. And then anytime another part of the same mesh gets installed, then it will add it to that instance static mesh component. There are some difficulties there because anytime you interact with the part, you have to update the instance static mesh transform in addition to the other one. So I hide the actual actor mesh when I change it to an instance static mesh. but you can still interact with it. So if you want to attach a wrench to it and torque it, then the instant static mesh needs to reflect that change. The only other problem is when you want to highlight it or have some material parameter change on it, then you probably need to stop instancing so that you can change a material parameter on a dynamic material instance, which you can do with instant static meshes, but it's a little bit tricky. So usually I'll just hide and unhide the instant static mesh, or vice versa, depending on what I need to do.
We pretty much just set that system up for engine components, though, because that's the low-hanging fruit of, like, you know, there's 16 of a bunch of these things, or, you know, there's 8 of a bunch of these things.
Right, if there's only 2 or 3 bolts on one thing, we don't use the instancing. Just complicates matters a little
But I
bit.
think
But, you know, now that UE4 has
the dynamic instancing, yeah, that helps
ahead.
a lot. Especially because our system never helped with uninstalled parts. So if you took a whole car apart, it couldn't instance loose parts on the ground. But I think the other big thing we do is we make everything scalable. So people can turn off dynamic shadows. They can turn off screenscape ambient occlusion. The ray tracing features we're adding are very user configurable. And that has, you know, our game with all the pretty stuff off, it hits the minimum VR spec. You know, we obviously had to pass through the Oculus Store system. They do a bunch of testing. Yeah, and it's interesting because I don't think the VR spec has actually changed, but the average user has better hardware now than they did like 3 years ago. And I think initially we only allowed 1 car to be rendered at a time or loaded on a lift. You could buy the parts for more cars, but you'd have to like manually purchase, and you know, people just didn't have 3 cars worth of stuff on screen. But now you can have 2 lifts. You know, we have work lights you can move around now, plus the flashlights. There's like extra shadow casting lights. There's definitely an element of, if you're in VR, you could try to make it run slow if you wanted. I mean, like, but like, just don't do that. Don't put 10 cars on screen.
And I think how I feel about all this is like, if people want to fill their garage with parts, at some point they should understand, you know, it's a simulation game, it's a sandbox game. You can't do everything you want and still have good performance, but you still should let people choose, I think, in this type of game. Like, I don't want to say you can't buy another part because you already have 1,000 parts in your garage.
Right.
There's just going to be a limit.
Say like, you gotta clean up first.
Give people ways. Yeah, we do have a trash can. You throw parts away. You can make them get removed from the shop. And eventually we're going to add more organizational support. So you'll be able to put parts in boxes, put them on shelves, and that'll unload them and remove their costs from the game. So
Quite a few things.
Yep.
Yeah.
A lot of little things here and there.
Let's see. They're wondering, how do you identify the part coordinates once they're like on the car? They're wondering if you implemented like a helper class or anything like that.
To identify the part coordinates.
I place a transform.
The parts.
Yeah, in the blueprints.
I don't know exactly what they're asking. We treat all the parts independently. So when a part gets installed on a car, you interact with it directly. There's no larger system that says this part's at this transform. It's still an actor in the world. It's not combined logically with the assembly. It's still the independent actor. So if you go to grab it, the grab mechanic, which is a combination of ray traces, sphere traces, overlaps. We do a lot of different ways you can pick up parts because we want it to feel natural in VR. It interacts directly with each part, and the part uses our assembly logic system to determine whether or not it can currently be removed. So if you try to grab a part, you interact directly with that individual part, but it just says, I can't be removed right now, so you can't grab it. So its transform is always just the actor transform, is maybe the short answer.
Okay. Some of the folks were wondering if you ever plan on using this as like a virtual teaching environment, maybe in a more formal setting, or if it's always geared towards being like, this is a simulator game, like for enjoyment.
That has been a topic of discussion, and we've put some effort into that in the past.
Here, I'll show a picture. This is something we considered showing originally, but since someone asked the question.
Is that the Hilton Head thing, or?
Yes.
Yeah, so it's interesting because it's like an edutainment game.
Right.
I think, and you know, there are a few dozen high schools at least that use this in their shop classes, and we don't do any sort of direct educational support because it's built as an entertainment product. And building a curriculum-oriented education product would be a pretty big undertaking, which we're not opposed to doing someday, but not right now. We're quite busy. But then we've also, we've done some exploration on like doing commercial simulation stuff, but we've just never quite. We've gone partway down those roads and just never quite decided that was the right move. I think part of it is Jim and I know video games pretty well, and this feels like a known problem and a known marketplace, and like it's less mysterious. Whereas like bidding jobs for big companies to do training simulations is a whole, I don't know, it's a can of worms.
I think they also, what we realized, we've talked to a few companies about it, and I don't think they understand how much it costs to make software.
Yeah.
It's custom software. I think to really get into this space, you'd need to have an initial investment and lay down a big framework for that, which is something we could potentially do, but we're just focused on Wrench right now. A lot of the systems in the game aren't easily separable from a Wrench game right now. Some of them could be with more work, but they're just not, because it would make the game take longer to make, and we're focused on that. But there's definitely been a lot of interest. It's one thing that makes the project unique too. We talk about that.
Yeah, we have weird traction with businesses. It's like hard to get gaming press to cover us because we're too niche for like mainstream game websites, but we can get like, people at Fortune 40 companies emailing us to ask things, and it's weird. Yeah, I think the other thing too on education that's really cool is we get user reviews occasionally, or talk to users who say like, "Hey, I've been playing a game for a while, and I just did brake service on my car. I never worked on a car before," and it's like, to me, that's the ultimate. Like,
That's
okay,
awesome.
we're doing a good job. People are like, yeah, really learning how this stuff works and feeling comfortable. And obviously, you can't take Wrench and just go work on your car without a shop manual. But like, if you can play
Right.
Wrench and digest what's there's a lot of service you can do in your car if you can follow your manual that you can do comfortably.
Some people have said, like, this has helped me get my XYZ certification for auto mechanics.
Yeah, someone used it as help studying for their ASE certification, American Society of, I don't know, not ASE. Yeah, their automotive certification.
Now, I will say this is a feel good about the project where, you can share it with your kids or your grandparents,
Yeah.
and they're not going to think you're out there making a first-person shooter where you're doing
It's
all
not a
kinds
murder
of
game.
evil things. So it's kind of nice from that perspective to work on a more educational game that has a no limit on the age audience.
Yeah, I remember when we first started, my daughter was like, I don't know, 3 maybe,
Mhm.
and I could put her in VR a little bit, and she would like interact with stuff and not fully grasp that it wasn't quite real. Pretty cool.
So
Confusing
those
her.
moments I feel like are always the most special. I've certainly seen kids like put on a VR helmet and then they go chasing after whatever was in the scene, and it's just like,
Yeah, you're like, oh
"You're
no, I
gonna
gotta
do it,
get you.
people," and like, please don't hit the table that's 3 feet from you, because the real world still exists. But and it all, I feel like that's the moment you feel like you've convinced them, like you've immersed them, and they're really here in that experience, and it's fun.
And also, I don't know if you're gonna show those Hilton Head pictures, Jim. I mean, that was
I
interesting.
did. I put them up
Okay.
a minute ago.
The you get a mix of people there who either do work on cars but have never done VR, don't work on cars and never done VR, don't work on cars, never done VR, and never played video games. And so to see what different people from different backgrounds do when they're like confronted with what is essentially a whole lot of information all at once, and me trying to explain to them where the buttons are on the controller while they can't see them,
And
it's
hold the
pretty cool to
cord
see when
for
people
them
can
at the
just
same
get it.
time. You're like,
Yeah,
holding
but
the
you get people though who have worked on cars before, and one of the people we licensed a car from, he just started putting stuff together. I gave him no explanation, never done VR before, but he's like, "Oh, I know these parts. I've handled these. I'm just going to start putting them together." And I was like, "Okay, that's awesome."
That's really cool.
Yeah.
So I'm wondering if you're going to continue focusing on like new cars, or do you have plans maybe for a variety of cars, if some folks are like want 40s or 50s cars versus modern?
Yeah, I think Jim and I talk a lot about how there's a lot of content in the game right now, but it doesn't necessarily look like it from the outside. It's like a really big vertical slice right now, and we want to broaden that. The issue is like as a 2-person dev team, it's many thousands of hours of work to make the content for a car. So like I
Mhm.
can't just go making 10 cars. That's just not going to happen. So I think a couple things, we're doing mod support at some point.
Oh,
And
very
hopefully we'll have the community fill in more content. And then we are going to build more. We're going to broaden it, but it's not going to be like Gran Turismo or something where there's a big library to pick from.
And
Sort of
we hope. I mean, there's several different licenses or licensing opportunities that we hope to fulfill down in the future that have very interesting overlaps with our game. We're not going to talk about anything specifically, but there's some we hope to get that would really enhance the content in our game, especially from enthusiast groups who know certain brands and that sort of thing. So we're always looking for potential partners, I guess. Want to have their kit, car, and wrench, and they haven't been in contact with us and that sort of thing. We still have a lot of other work to do too. That's not just the pure content. We want to refine the game loop. We've done several passes on it since launch, and it's at a pretty good place now where someone can have a pretty good multi-hour, dozens of hours experience in the game and not run out of things to do. But we want to make it even better with one more iteration on that, and we have a lot of ideas going forward for that. So there's still a lot of work on the content side and the game loop side. Also, plenty of polish left to do, but it feels pretty good these days, I think.
Well, it certainly looks great.
Thank you.
Are you exploring? Oh, well, speaking of how the game feels, are you exploring like controller-free or hand tracking devices in the future?
I have not. I guess I'm in favor of let's converge VR input devices to a standard because it's such a pain. I think some of that stuff would be cool. We have so many small parts and need so much dexterity that then you kind of like analog pinch pickup, I think could really quickly become impossibly fiddly. I don't know. I haven't used those systems, so maybe it wouldn't be. But it's also sort of like how many hours of work is it for how big is the audience for those devices? It's already, again, with two people, we have limited resources. We've got to figure out what's efficient to do.
Yeah, I know when the Valve Index came out, it has the finger tracking, which we considered adding better support for that. But I also thought about how it would actually work in our game, and I don't think we ever found a particularly convincing use out of that. I mean, we have a pinch in our game, which is very handy, but having like a proportional force for pinch wouldn't add much. We have very intentional interactions. So you pick up a bolt, you don't want to drop it. You don't want to hold it gently and then bump into something and drop it. You just want to hold it. There may be a few cases we could come up with if we really wanted to, but generally we didn't think that it would be worth the effort to support that stuff in the game. It might be good for visually seeing your hand move in the game, but we never incorporated that, at least not yet.
So what did you wish you knew or did when you first started building your VR game? I know we talked a little about, like, you'd mentioned maybe not going into early access as soon as you did, but what's something you felt like out of the gate you wish you knew when you had started all of this?
That's a tough one because I feel like if I had known a lot of things, I wouldn't have done it.
Oh no!
So yeah, I don't know. I think I would have had.
The mystery was actually helpful.
Yeah, I think I would have had different expectations around an early access launch and where the game needed to be. It's hard though because we didn't really have a choice. It was launch or not have a game. So yeah, I don't know. I mean,
Alec always jokes with me. He's like, I wish we could send our current build back in time. That's what he wants to
email it back to. I mean, that launch would have gone very differently. Also, I guess one thing I would have wished we'd known. I wish I understood how the Steam store worked at all, or being on the Steam store. We launched on December 18th, 2018. December 19th, 2018. The Steam winter sales, holiday sales, started on the next day. I didn't know that. So like we were a top seller briefly, and then all the store presence was gone like immediately. And I didn't have a clue. We were really busy. Like I probably should have figured that out, but we were working super long hours and really in what we were doing. There's a lot of stuff like that. How to market, how to do the community side. Yeah, those are things you don't learn.
That stuff is still confusing, though. I'm not sure we know about that anymore. Maybe a little bit.
The marketing side, especially. Yeah, it's pretty hard.
I think one thing, you touched on there is like I don't know if the project would have started. I I think being a little bit naive about indie development is part of the beauty of it, because I mean, I experienced this with various levels of programmers. When you have a novice programmer who doesn't know what not to do, they're often willing to do more. When you have like an old programmer who's got too much experience, sometimes they'll decide not to even try to do something because it's not going to work, and they're already set in their mind that it's not going to work. So I think naivety is like a tool for indie developers. And when you don't know what the future is going to hold, you can still change your path. I don't know. It's just
The thing that's challenging about that is like if you go all in something and all of your financial future is staked, like I don't know, it's a fine line between making it like a good, smart decision and being overly cautious.
I think, yeah, and part of that is like, we mentioned how we were uncertain about the future of the project originally, and we weren't sure that I was going to be on there, and part of that was due to finances, with mouths to feed and all that stuff. You can't just work on a project that doesn't generate money, so we had to figure that out.
We don't have a publisher. I mean, we're self-published. We don't have, which is there's pros and cons. We don't have a payback scheme, so.
We did talk to a publisher too, and it was hard to find the right amount of money that they would be willing to pay and then give up the control over the creative process. There's probably a publishing agreement out there that would work for us, but it's hard to imagine what it would be. And we still have a lot of...
The thing is, if we did it, the whole point would be to hire more people and scale the team. That'd be the entire purpose of it. And so it's like, is there a publisher out there who will let us do that in a way that the terms are favorable?
Yeah, maybe. All these the publisher thing is a whole another difficult concept to navigate. I have a lot of other indie dev friends, and they've had some positive, some negative, some neutral experience with publishers.
It really depends on your game and your team and the publisher and the whole dynamic. And so there's certainly no one size fits all solution. And I know we've done a couple of write-ups on our blog. Had guest authors kind of write about different, what it's like working with a publisher, like the different kinds of relationships or deals you can have with publishers. And then ultimately you have to decide whether that works for you or not, so.
One positive thing about not having a publisher is this is like a positive and a negative. There's no pressure on us to release a feature on a given date. So if we want to take an extra day or two to polish something in the game, like recently I worked on these caster physics. So some of our shop tools have casters that allow the tables and the engine stands to roll around, and they look really nice when they're moving. We have a procedural animation on them. You can lock them, which I wrote like a custom 2D physics solver so that the casters operate correctly if you lock one of them and then try to move it. And that's something that I feel like would just get overlooked if you have a publisher who wants the product to go out on time.
But it's funny because that's like, it sounds trivial, but that's actually like strangely fun in VR to like be pushing an engine stand around and have it pivot on a locked caster. It's the kind of stuff that, it's pretty satisfying, and it would definitely get cut.
The little details that I feel like that really sell some of those experiences. So
hopefully, because it takes time to write all those little details. Maybe
I know things are also fun for us, though. I feel like sometimes we get tired of doing something that's kind of tedious, and it's fun to jump into something like that. It's almost for ourselves sometimes.
I mean, I would say you have oodles of very positive reviews, so I would think that your community would agree that they like those changes you're adding. So
I think our review score is pretty good because the game's in pretty good shape at this point. But I think more than that, I think this genre is pretty underserved, and people can tell this is an enthusiast game, and that people are who make it actually care. It's not a cash grab. So they're more forgiving, and they appreciate the work that goes in.
Yeah, each of these assets is very much generated with a lot of attention to detail and time and effort on both of your parts. So
yeah.
Well, I think we're about ready to wrap up. Do you have any parting words you would like to bestow upon our community?
It's great doing this. We never get to talk about our game or show people our game, really. So it's pretty cool to get to show what we've been working on.
Yeah, I think it's been great too to talk about it. I know as a solo programmer, I mean, I have Alec as the co-developer, but I'm the only programmer on the project, so sometimes it's really hard to solve problems without another programmer to talk to. And this is kind of a nice little outlet to discuss a few things. I mean, there's not a lot of discussion. I guess it's more of sharing, but just let anybody else out there that's working on an indie project and they're the only programmer. I understand it's not always easy. Just keep trucking along and find some friends to talk about if you have issues. I keep track. I do have some old dev friends that are really helpful to occasionally bounce ideas off of, but they're not always available.
Well, we certainly always encourage people, to join online communities, whether it's in our ecosystem at the forums if you have questions, or community meetup groups that are local folks that you can actually go and hopefully soon really go show off your projects and get hands-on player feedback, or community Unreal Slackers is super amazing. So if y'all haven't been over there in those Discord forums.
Yeah, especially earlier, I posted on there a lot. I'd be like, how do I make the motion controller do this?
Help me.
Yeah.
There's also a really great Unreal Developers Facebook community. So yeah, I think it's definitely, I agree, lean on the developers around you and share, whether it's just to get feedback on your work in project progress, or just sometimes putting it in front of another person gets you, kind of like you were talking about during your early access, right? Just putting it in front of someone else's eyes and getting to step away and try to look at it through how they're experiencing it can enlighten you to the experience you built.
That's been a really interesting thing watching people Twitch stream our game. Is we find ourselves there's been various points we find ourselves very tense watching someone. We're like, oh, we know these systems don't work well enough if we're nervous to watch someone play it in front of people. It's useful to have
those early Twitch streams were it was hard not to cringe when we were watching people. These days though, I think anyone that streams it or records it, it goes a lot smoother. So it's much better for us when we can watch someone and not have to cringe the whole time.
But no, I was telling for the community folks out there, I remember when we first at least discovered you from our side and had done the NVIDIA Edge program and stumbled across Wrench, and we're just like, oh wow, this is awesome. And just to see how far it's come is, you all have put in so much time and effort and just passion into this project, and it really, really shows. So, props to you two. And thank you both so much for coming on and chatting with us about Wrench today. For folks watching at home, you can download Wrench on Steam, or if you'd like to check out their website, it's wrenchgame.com. So, follow along the progress and see what you all keep working on in the future.
Yeah, well, thanks for having us. This has been fun.
Yeah, thank you.
It's our pleasure. We will see the community folks in 2 weeks. We do not have a stream next week. So take a break, hang out with us on social in the forums, and stay tuned for all things Unreal very soon. Thank you all for coming out, and thanks again to you two for all the cool information on Wrench.